Article 400 of the National Electrical Code covers flexible cords. UL Standard 62 publishes ratings and properties of flexible cords. To find the temperature rating and amperage rating of various types of flexible cords, consult the National Electrical Code, specifically Table 400.4. Table 400.5 provides ampacity adjustments for flexible cords used in different temperatures. UL Standard 62 is available for download from the UL website. Refer to the appropriate table within the standard for the type of flexible cord you are using. This table will list the temperature rating and amperage rating. For a fixture with a non-adjacent ballast connection, a 90-degree cord with no conduit entry is acceptable. For the fixture requiring wiring in the ballast compartment, it will be necessary to use a flexible cord rated for at least 150 degrees Celsius and should be sunlight resistant. Examples of sunlight-resistant cords include Belden 1482A, Whitney Blake FW2, and Savware Romex 12/2 UFB sunlight-resistant. It is important to always refer to the manufacturer's specifications for the specific cord being used to ensure compliance with temperature and sunlight resistance requirements. It is also important to understand the context of where these cords are being used. The National Electrical Code is a comprehensive set of standards that governs electrical installations in buildings and other structures. It is updated every 3 years, and it is widely adopted in the United States and other countries. The purpose of the NEC is to safeguard persons and property from hazards arising from the use of electricity. Article 400 of the NEC specifically addresses flexible cords and cables. This article provides requirements for the construction, installation, and use of flexible cords. It covers various aspects, including the types of cords permitted for different applications, allowable ampacities, and proper termination methods. Understanding Article 400 is crucial for ensuring the safe and compliant use of flexible cords in electrical systems. UL 62 is a standard developed by Underwriters Laboratories that covers flexible cords and cables. This standard specifies the construction, performance, and marking requirements for flexible cords. It includes tests for physical properties, electrical characteristics, and flammability. Compliance with UL 62 ensures that flexible cords meet certain safety and performance criteria. Manufacturers of flexible cords often seek UL listing to demonstrate that their products have been tested and meet the requirements of UL 62. This listing provides assurance to users that the cords are suitable for their intended applications and meet industry standards. When selecting flexible cords for electrical applications, it is essential to consider both the NEC and UL 62. The NEC provides the installation requirements and guidelines for using flexible cords in a safe manner. UL 62 ensures that the cords themselves meet certain performance and safety standards. By adhering to both the NEC and UL 62, electrical professionals can ensure the safe and reliable use of flexible cords in electrical systems. Temperature ratings for flexible cords are crucial for ensuring safe operation and preventing overheating. The temperature rating indicates the maximum temperature that the cord can withstand without degradation of its insulation or other components. Exceeding the temperature rating can lead to insulation breakdown, short circuits, and even fire hazards. Flexible cords are typically rated for different temperature ranges, such as 60 degrees Celsius, 75 degrees Celsius, 90 degrees Celsius, and higher. The appropriate temperature rating for a specific application depends on the ambient temperature and the heat generated by the electrical current flowing through the cord. In general, it is advisable to use a cord with a temperature rating that is higher than the expected operating temperature to provide a safety margin. Ampacity ratings for flexible cords specify the maximum amount of current that the cord can safely carry. Exceeding the ampacity rating can cause the cord to overheat, leading to insulation damage, voltage drop, and potential fire hazards. The ampacity rating of a flexible cord depends on several factors, including the wire gauge, insulation type, and ambient temperature. Thicker wires have higher ampacity ratings because they have lower resistance and can dissipate heat more effectively. Different insulation materials also have different temperature ratings, which affect the ampacity of the cord. The NEC provides tables that list the ampacity ratings for various types of flexible cords based on their wire gauge, insulation type, and ambient temperature. It is crucial to consult these tables and select a cord with an ampacity rating that is sufficient for the intended application. When using flexible cords in high-temperature environments or when carrying high currents, it is essential to direct the ampacity rating to account for the increased heat. Directing factors are provided in the NEC and should be applied to the ampacity rating to ensure safe operation. Sunlight resistance is an important consideration for flexible cords that are exposed to direct sunlight. Ultraviolet radiation from the sun can degrade the insulation of flexible cords, leading to cracking, discoloration, and loss of flexibility. Sunlight-resistant flexible cords are made with special insulation materials that are designed to withstand the damaging effects of ultraviolet radiation. These materials typically contain additives that absorb or reflect ultraviolet light, preventing it from reaching the underlying insulation. Sunlight-resistant cords are commonly used in outdoor applications such as lighting fixtures, portable tools, and extension cords. When selecting flexible cords for outdoor use, it is essential to choose cords that are specifically labeled as sunlight-resistant or UV-resistant. These cords have been tested and certified to withstand prolonged exposure to sunlight without degradation. In addition to sunlight resistance, other environmental factors can also affect the performance of flexible cords. These factors include moisture, chemicals, and mechanical stress. Flexible cords that are used in wet or damp locations should be rated for wet locations and should be protected from water damage. Cords that are exposed to chemicals should be resistant to those chemicals to prevent degradation of the insulation. Cords that are subjected to mechanical stress should be durable and resistant to abrasion and impact. When selecting flexible cords for specific applications, it is essential to consider all of the environmental factors that may affect their performance. By choosing cords that are rated for the appropriate environmental conditions, electrical professionals can ensure the safe and reliable operation of electrical systems. Ballasts are electrical components that are used to regulate the current flow to lamps, such as fluorescent and high-intensity discharge lamps. Ballasts can generate significant amounts of heat, especially in enclosed fixtures. When wiring fixtures with ballasts, it is important to use flexible cords that are rated for the appropriate temperature and that are suitable for use in ballast compartments. Ballast compartments are typically small and enclosed, which can lead to high temperatures. Flexible cords that are used in ballast compartments should be rated for at least 90 degrees Celsius and should be resistant to the chemicals that may be present in the ballast. In addition, the cord should be properly sized to carry the current required by the lamp and ballast. When wiring fixtures with ballasts, it is important to follow the manufacturer's instructions and to use the appropriate wiring methods. Improper wiring can lead to overheating, electrical shock, and fire hazards. It is also important to inspect the wiring regularly for signs of damage or deterioration. Damaged or deteriorated wiring should be replaced immediately to prevent electrical hazards. The National Electrical Code provides specific requirements for wiring fixtures with ballasts. These requirements cover the types of flexible cords that are permitted, the ampacity ratings of the cords, and the wiring methods that must be used. Electrical professionals should be familiar with these requirements and should follow them carefully when wiring fixtures with ballasts. Flexible cords are an essential component of many electrical systems. They provide a flexible and convenient way to connect electrical devices to power sources. However, it is important to use flexible cords safely and to select cords that are appropriate for the intended application. By following the guidelines and requirements of the National Electrical Code NEC 62, electrical professionals can ensure the safe and reliable use of flexible cords in electrical systems. Furthermore, understanding the nuances of flexible cord selection, including temperature ratings, ampacity ratings, and sunlight resistance, is critical for ensuring the longevity and safety of electrical installations. The information provided in the NEC and UL standard serves as a valuable resource for electrical professionals in making informed decisions about flexible cord applications. In summary, when dealing with flexible cords, it is crucial to firstly consult the National Electrical Code, specifically Article 400, for requirements on flexible cords and cables. Secondly, refer to UL Standard 62 for ratings and properties of flexible cords, ensuring compliance with construction, performance, and marking requirements. Thirdly, consider temperature ratings, ampacity ratings, and sunlight resistance when selecting flexible cords for specific applications. Fourthly, pay attention to the manufacturer's specifications for the cords being used to ensure compliance with temperature and sunlight resistance requirements. And fifthly, follow proper wiring methods and inspect wiring regularly for damage or deterioration. By following these guidelines, one can ensure the safe and reliable use of flexible cords in electrical systems.